Alright everyone, we're going to review electron configuration today, and we're also going to add some stuff that we didn't have last year. But I want to show you this picture because I know we talked about quantum mechanics before. I found this picture off a conference in 1929, and I wanted you to notice who was in this picture. This was all at one conference, at the same time, and we've got some pretty impressive people here. Here's Schrodinger right over here. Wolfgang Pauli is right over here. Next to him is Werner Heisenberg. And let's see who else we have. Down over here is Niels Bohr, kind of crouching down and looking over. Here's Max Planck, Marie Curie with her 2 Nobel Prizes, and Albert Einstein is right here. And right in between is de Broglie right over there as well. So by my count, there's 7 Nobel Prize winners just in this picture that I know of, and there might be a few more in there as well. So you guys remember Heisenberg's uncertainty principle and Wolfgang Pauli's exclusion principle and so forth from last year? All right. Seem to really be excited about it. Okay. So what I want to do is I want to review electron configuration and then just add a couple things. So think back to last year when we did electron configuration. That was like the 1s2, 2s2, 2p6, and so forth. You guys have your periodic tables? Okay. So what I'd like for you to do is do a little pre-assessment. This is not going to count against your grade or anything like that. It's just to see where you are. I would like for you guys to write down the electron configuration for aluminum for me. You guys can do the longhand. Aluminum is fairly short. Just put your pen or pencils down so I know. Alright, so if you got it right, thumbs up. If you got it wrong, thumbs down. If you got it somewhat right, halfway right, kind of right, thumbs in the middle. There is the electron configuration. So let me see what we got. Alright, excellent. Alright. Okay, so what we're going to do is, I'm going to show you guys the arrow diagrams. Now this is something we didn't talk about last year, but we're going to include it this year. And what we're going to do is, on your periodic tables, I want you guys to add something. And I want you to label this suborbitals. Remember that the S is an orbital, the P is an orbital, the D is an orbital, and the F is an orbital, but they break down into smaller parts, and those small parts are called suborbitals. And it's really easy. It goes by the odd numbers. So up over here, the S orbital has 1 suborbital. So 1 suborbital. The P has 3 suborbitals. The D has 5 suborbitals. And the F has 7 suborbitals. So what we have are just the odd numbers, 1, 3, 5, 7, and we jump just like we normally do, 1, 3, 5, 7. So we just jump all over the periodic table, following the S, the P, the D, and the F. Okay, so let's do aluminum. So we have aluminum up there. 1s, now we just said that we have 1 suborbital in the S, so we do 1 box to represent the suborbital. Here's 2s on our electron configuration over here. So that's 1 suborbital again. When we get to the P though, how many suborbitals in the P? 3. So we always have to draw all the suborbitals in. We can't leave them out. Even if we're not going to fill them, we still draw them in. Then we have a 3s, once again just a single suborbital. And then 3p, once again the P has 3 suborbitals. We only have 1 electron according to this electron configuration. It's 3p1, but we still have to draw all 3. Okay, so this is really simple. These electrons that are represented by these numbers over here are now going to be represented by arrows. And they're represented by up arrow and down arrow. Anybody tell me what the up arrow, down arrow significance is?
Is it the spin of the electrons?
Exactly. So if it's spinning up, it's spinning in one direction. If it's spinning down, it's spinning in the opposite direction. So we have 2 electrons in one s2, so it's an up arrow and a down arrow. 2s2, up arrow, down arrow. Then we get to 2p6 right over here. Now there's a rule for this, and the rule is called Hund's rule. And if you review your notes from last year, you have Hund's rule in there. And this is what it says. You have to put in, there's 6 electrons first of all. You have to put in all of your up arrows first, and then you come back and you fill in your down arrows. And the reason is that the first 3 electrons all go in spinning in the same direction, so they have the same magnetic signature, and then you come back, and then the 4th electron will spin in the opposite direction, canceling out the other magnetic signature, the other electron that's in its suborbital. So that's why we have that. But that's Hund's rule. Then we have 3s2, up arrow, down arrow, and then 3p1. And since we only have 1 electron, we put in our single up arrow, and the rest of the suborbitals are left empty. Alright? So this is what I didn't cover with you last year. What I need to do is get a quick take from you guys over here. How many of you feel thumbs up, down again? How many of you got this? Pretty simple? Okay. Alright. What we're going to do is we're going to relate this to the 4 quantum numbers. The 4 quantum numbers, also review from last year. This stuff is new, but let's throw this in real quick. If you guys remember, we had 4 quantum numbers. We had N, we had L, we had M sub L, and we had M sub S. Those are our 4 quantum numbers. Using these 4 quantum numbers, we can find any electron in here. Every single electron has a unique set of numbers. It's their signature. And so it'll help us locate any one. And this is really straightforward. So let's pick this one over here. Anybody have a preference? We've got 6 electrons over here. Which electron do you want? 1 through 6? 4? Okay, so this electron right over here. Okay, that's the one we're going to look at. Here, I'll change colors. There we go. Look at that. Alright. So N, the first quantum number, is for energy. Really easy to figure out. It's that number right over there. Whatever orbital it's in, it's the number that goes in front. So its energy level is 2, right there. So let's look at this electron here real quick. What's its energy level? 33. Right. Okay, so the L, also review from last year. For the L, if it's in an s orbital, its L is 0, P is 1, D is 2, F is 3. So right over here, we're looking at this electron again. It's in a p orbital. So what's its L going to be? 1. All right. This we did not cover last year. The M sub L. Now I want you to think back a little bit to the number line that you guys learned when you were in elementary school. We had the number line, we had the number 0, we had +1 over here, +2 over here, and we have -1 over here and -2 over there. In quantum mechanics, we use the same sort of concept. We go to the middle suborbital, and we give it a value of 0. So that's our 0 on the number line right over there. And then we go to the right, that has a value of +1. And the suborbital on the left has a value of -1. And so, right there, we can just look right up there. We can look and see which suborbital, which box our electron is in. And we look at the number above it. Okay? What's our M sub L for this one? 0, right? The S, they're always 0. S is always 0 by definition because there's only one, so it's its own center. What do you guys think about this? Is this okay right over here? You want me to go over this one more time? Okay. Good? Yeah? Okay. Alright. And then the final one, this is the easiest one of all. M sub S, if the arrow's facing up, it's +half. If the arrow's facing down, it's -half. So here we have an arrow facing down. What's its M sub S? -half. Okay? There we go. Questions on this? Alright, this is what I would like for you guys to do. I'm going to circle one over here. Right there. And I would like for you guys to tell me what the 4 quantum numbers